Hello, my name is Hugh Ortiz, and this is my Projectile Motion Lab 2 video. So some introductions. The purpose of this lab is to compare the positions of an object as it falls experimentally, which we will use, which we will do by using a tracker, and computationally, which we will use to using GlowScript. Then we will further compare the computational models by comparing like the effects of drag. We're gonna do this by recording a video of us throwing an object. So some key concepts about this. For this lab, we must keep in mind gravity, which is negative mg on the y vector, and drag, which is negative v times velocity squared times v hat. And that combined will be our net force total. And some further key concepts. Obviously, our position update formula, final position equals initial position plus velocity average times delta t, and then our velocity update formula, which is velocity final equals initial velocity plus acceleration times delta t. So this is my video, and some analysis about this. In order to find velocity, you must do final position minus initial position divided by time. And after doing this, you will, well, what I did was, you know, 0.487 minus 0.390 for the x value, and then 0.94 minus 0.978 over 0.033, because that's like the frame rate of this video. And that gave me my initial velocity of 3.232 for x value and negative 0.3030 for the y value. And this is my GlowScript code. For drag, for the first model, I put drag to 0 so it wouldn't, calculate that. But once once we had to calculate drag, what I did was put 1, and yeah. For net force, just gravity, ball mass times gravity negative, and net force equals net force of gravity plus net force of drag. And here is our velocity update formula, position update formula. And here is the GlowScript model. The one on top is my no drag model. And as you can see, x position linear, y position is not. My bottom one is included drag plus gravity. So, and now some comparisons. Green is my tracker, my experimental model, and the blue one is no drag. Orange one is drag. So what are some deviations from this video? Obviously, it could have been like a personal error when I was doing the tracker. It could also be like some tracker errors, and obviously computational, the first one didn't include drag. For terminal velocity, does any of my models predict terminal velocity? I think my no drag one does not include terminal velocity because it goes linearly forever. However, I think the one that includes drag does show terminal velocity because it begins flattening into a horizontal asymptote. Now, what if we threw it out? Would it take longer for it to come down, yes, it will take longer because it slows down due to gravity. It stops momentarily at the top, then it accelerates downwards. Only after that does it pass like the original like position, and the extra time upwards increases the time. And here's the formula, which is time equals velocity of an iron issue over gravity. And yeah, thank you.